Hi friends, good morning. Welcome back in your math channel Maths in Nutshell by Mahesh Sen. Today we have the section formula or the derivation of the section formula. Let's do it here. What is that? P is x1 y1 and the Q is another point x2 y2 are the 2 points. Suppose these 2 points are here, whose coordinates are there and both the points are in xy plane. And suppose let mxy be a point which divides the line segment internally in ratio of m ratio n. So basically guys, we have to find out the section formula, what is their section formula and how we will use in this whole exercise 7.2. Basically 2 points are there and one point m which divide this p and q in two parts. So let's have look at in the xy plane. P and q are the points and P and Q whose coordinates are also given x1 y1 and x2 y2. These are the 2 points and we have a point M which section which divide this in some line segment in some ratio. That ratio is m1 m1 m n1 ratio or m ratio n. So point M is x comma y and it divides in m ratio n. Right, so this PM and MQ are in ratio M ratio N basically. So this is the line segment. Now we will go for the derivation. We will draw the P and Q perpendicular from these 2 points on the x-axis. Join P to this line, M perpendicular and Q perpendicular from the M. Right. So these are the 2 triangles we are making here and we can put these names of these coordinates. The coordinates P R is the perpendicular distance, MS and QT. Similarly this ME and PF. Right. So we can give the points of the intersecting point of these perpendiculars and this is PF, ME, P R like this. So we can see here there are 2 triangles, one is green one and the pink one. These 2 triangles will go with the derivation, but before derivation we will have this derivation. We have to prove these 2 triangles are similar first, and if the 2 triangles are similar, and then we will move for the triangles are similar and then their ratios are equal, the concept of the similar triangle. So guys, we know that these 2 triangles are right angle triangle, as we know E and F are the right angle, and we will go with the proof these 2 triangles similar. So we'll go for the angle property and we'll find out 2 angles here equal. Basically 3 angles should be equal, but 2 is enough because the third will automatically equal. So in triangle PMF and QME, these 2 triangles, we have angle E and angle F are equal. Why these 2 are equal? Because with 2 angles are 90 degree each. So these 2 angles are equal. Second thing, angle P and angle M, these both are also equal because you can see here this angle M and angle P are corresponding angles. So when this ME and PF are parallel lines, so P and M will be equal corresponding angles. So you just write the reason here why these 2 triangles are equal. Okay, after this we'll move towards the criteria. If you know very well, the last chapter we have done the triangles. Triangle may you have some idea regarding the 2 triangles are similar if these 2 triangles are by the angle properties, right? So here also PMF and QMF are similar here. Why? Because angle property, right? So by angle property, the triangles are similar and we know that very well. The triangles are similar, then what happens? The ratio of their corresponding sides are equal. So PM upon MQ, PE upon ME, you can see the diagram, and the last one is ME upon PF, right? These 3 sides, the ratio with the corresponding sides are always equal. Now guys, we'll go further with the help of this criteria only. We'll go and we'll find out this PM first. So what is PM? You can see the diagram. PM is small m, PM is m, MQ is n. The ratio are given, that's why. The next one is we are finding everything. PF is PF. You can see the diagram. PF is x minus x1. Yes, you can see the whole diagram here, x minus x1. Next one is P, yeah, this MF is x minus x2 minus x only. Yes, x2 minus x. From the diagram you can see, guys, this is the total minus the x2 minus x1, the bigger minus smaller one, right? After this we'll go with this mf is also very simple, y minus y1, and mf के बाद में we have this qe, just qe in the triangle only, qe. You can see the diagram, y2, right, this is y2, the total distance is y2, and y is the second distance, so y2 minus y, right? Y only, not y1. Okay, right, y. So diagram is clear. The values or the line segment we have kept here. Now putting these values in the given ratio, so pm upon mq, that is m upon n, is equals to x minus x1 upon x2 minus x1, this is okay, is equal to mf upon qf, so mf is y minus y1 and y2 minus y1 in the upon, right? Now guys, we know that the three ratios are equal here, so when you are solving, we generally take the two ratios together. M upon n is with x minus x1 upon x2 minus x1, and then m upon n is with the last term. Okay, so we'll draw a line and we'll do it in the left hand side, the first two ratio and then the other two, right? M upon n is x minus x1 upon x2 minus x1, x2 minus x, will cross multiply, x2 minus x1 will go in the multiplication with the m, and n will multiply with the x minus x1. So this will be cross multiply, as I have crossed here, m into x2 minus m into x is equal to nx minus nx1. Okay, and I'm direct multiplying it. Okay, after this we'll take common mx and nx together, so this will be going together. I mean mx is the left hand side to right hand side, and nx1 is left hand side. So mx2 plus nx1 is equal to nx as it is plus mx1, right? We know that after this left hand side may no change, so we'll copy down as it is this mx2 plus nx1, but in the right hand side we have x common, so we'll take the x common from the right hand side, and left hand side may no change, so just write it down as it is, the term logic. x2m plus nx1 is equal to x is common because x is common in both the terms in the right hand side, so m plus n in the bracket. We want the value of x basically, so this m plus n will go in the denominator, so mx2 plus nx1 upon m plus n, this bracket will come down. Okay, so this is your answer of x, or the value of x. So basically this section formula gives the value of x and y, which are the coordinate of point m or p, we can say. The second thing is we'll have the m upon n with this last term y minus y1 upon y2 minus y. I'm writing here y2 minus y. Yeah. So m is again multiplied with the y2 minus y1, and n is y minus y1 के साथ में, right? So m y2 minus m y is equal to n y minus n y1, right? Again the same story will repeat here as we done in the left hand side. This my will go in the right hand side, and n y1 will go in the left hand side, as we know that the like term will together. M y2 plus n y1 is equals to ny plus my, it will be plus now. So again no change in the left hand side. I'm writing here my2 plus ny1. In the right hand side yy is common, so we'll take the y common in the right hand side, right? So no change in this, so copy down is equal to n and y is common, the m plus n in the bracket. So now this y plus n will come down after this my2 plus ny1 whole upon m plus 1 in the denominator is equal to y is here. Okay, so I'll put in this bracket or in the box only this y equals to my2 plus ny1 upon m plus n. So guys, basically this value of x and y are the coordinates of point m. So by the section formula we generally find out the coordinate of the point which divides the line segment. Basically a line segment is that, so uske coordinate honge x and y. So this x and y, the value of x and y is known as the section formula. Okay, I hope so you understood this section formula, how this is the derivation. We'll apply this concept in directly in the sums. One more thing I just want to include this section formula. Generally we have the point P and Q or AB, and whose a point is divides into some ratio. So ratio may be internally, may be externally. This time we have the internally ratio. 10th class is only internally. In the 11th class and 12th class you will get the ratio divided by a point externally also. So I'll give the formula for sake of your knowledge only. So basically when you are having the internally, there will be a particular formula. P and Q are the points, M is any point, and whose coordinates we are finding. So by section formula we are finding the coordinates of the point, right? X1 y1, x2 y2, r is xy, and the coordinate of x is what. So basically coordinates of P and Q are given, the ratio is m or n is given. What I did beta, generally in many of the books generally m1 m2 is given at the place of m and n. N we generally don't write, so m1 m2, right? So coordinates of point x comma y, or coordinate of point P r will be x comma y is equal to x equal to m1, yes, that I wanted, m1 x2 plus m2 x1. This is very simple, m1 to 1 upon m1 plus m2. Similarly y will be here m1 y2 1 to 2 1. So m1 y2 plus y2 m2 y1 upon m1 plus m2. This is called the section formula basically, and this is applied for the internally division of the line segment internally by division by any point, right? So I think this internal division is okay. It generally comes in the 10th class and 11th class. I just want to tell you some extra thing that the externally division, what is the formula for the external division, but in the 10th class you will get only internally. So for your sake of knowledge and the higher understanding, a point is given to you, P, suppose x comma y, and the line which divides the line segment, and we'll take it x1 y1 x2 y2, right? So this P x comma y divides a line segment. It may be a line segment A, B, or PQ or MN, anything like that. So a line segment and whose coordinate will always be given to you. I'm taking the line segment AB, so x comma y, x1 comma y1, and B is x2 comma y2. And the important thing is we have done this just now, but important thing is I just want to explain you externally, right? What is the difference? What is the section formula for externally division, and what is the section formula for internally division? Both the things you should know about, right? So what will be the point or coordinate of the point P, that is P comma x comma y. So this formula is same, only the sign will be changed here. I'm telling you guys, this is very simple. So x is equal to m1 x2, this is fine, x2 m2 x1. So I will put here minus sign. If you notice, both the formula is same, m1 minus m2, right? I will put here plus, that it will be internally. I will put here minus, it will be externally. So y is m1 y2 minus m2 y1 upon m minus n. वहाँ पे m1 minus m2 और m1 plus m2 था, यहाँ पे m1 minus m2 and m minus n. You can say internally and externally में difference is only plus and minus. Externally minus, internally plus. That's fine. So I hope so you understood this concept and the derivation of the section formula. And if you understood, and if you like the video, please click on the like button, click on the comments, whatever you want, which kind of the videos you want. And the last and very important thing, guys, you will get the each and every notification of the video. So subscribe my channel. Thank you so much. Bye bye. Take care.